Assalamualaikum dan salam sejahtera. Okay, I would like to explain about the method in chapter 2, which is we have 8 method. So in this video, I'm going to share about 3 methods, which is separation of variable, homogeneous, um, and exactness. Okay, so this video I will explain one example of each method. So first of all, I want to explain separation of variable. Example 1 for separation of variable. I hope first of all, I hope you don't mind with my background music, because yeah, it's a chilling time to hear some song, right? Okay. So first of all, let's we look to the equation for the example 1. The equation is x minus 1 to the power of 2 y dx plus x to the power of 2 in the bracket y plus 1 dy equals to 0. So what can we do? So we can separate it to the both sides, so it will look more simple lah. So we know how to do. First of all, we bring the x square bracket y plus y 1 dy to the other side, so it will look like negative x square negative as because we transfer it to the other side. So to make it looks more easier, we bring the y and x square to the side which is same with them, like x minus 1 square over x square, because we want to integrate it with dx, and also for the other sides, y plus 1 over y here. Next, because as we have dx, so we integrate, and we integrate this to the respect, both sides to the respect of x and y, because this is dx and this is dy. So how to make it looks more easier to integrate? So I don't write the simplest, I just write it to make it simple. So actually it will become like we need to expand this is this x minus 1 over is x minus 1 square, and we expand and we divide with x square, so we will get this equation 1 plus 2 over x plus 1 over x square dx, and also to the other side, so it will look like this. So as this is a very simplest one, so just integrate and we will get the answer x plus 2 ln x, because why is 2 ln x, as we know, integrating 1 over x, it will become ln x. So like this we can separate it actually, so 2 will be outside because it is constant, so 1 over x, and we just integrate as usual. So that's all. Okay, next we move to the second method, which is homogeneous coefficient. For this section, okay, I want to okay I'm sorry, let's resume. Okay, for homogeneous coefficient, we need to put k in the function because we want to determine whether it is homogeneous or not. So to determine it is homogeneous, it will give an output exactly how output like this, like k square, and we get the exact equation. So I think this is simple, and I hope I can understand this more. Okay, and the third okay, let's we look first into homogeneous function, which the other example is just same, we just put k into the function, but to to solve the question, we need to use the technique substitution, which is Dr. Ma has explained it at the last class, I think. So for this one, after we know that the equation is homogeneous, yes, we get the degree and get the exact function. So we substitute, we let y equals to vx, and we differentiate, it will become dy equals to v dx plus dv. So this how to get this, we use product rules. Okay, I put here product rules. Then we just, from this equation we substitute the y equals to vx into this is equation. So from that, we after we expand it, we need to separate the variables and we will get the exact answer. So actually for all most of the methods, we need to use the integrate methods. So for method 3, I will explain on other video.